Hello, everyone. Good morning, good evening. Uh, I'll be your tutor for this course, and I will be providing you some information into system design, how systems are designed for simple to complex architectures. The idea behind this course is that we will be uh, learning it through actual use cases. We'll start with Netflix. So I'll be starting with a little introduction as to what is system design, how it is coming into picture, and how complex architectures have actually solved a lot of the problems that with smaller applications people generally face. I hope I'm audible. Can please someone raise their hand and let me know if I'm audible or not?
Yeah, you are audible.
Okay, great, Ramani. Thank you. Yeah, let's just get started. So I'll be sharing my screen. Please let me know if it is visible. Is my screen visible to everybody?
Yes, it's visible for me.
Okay, sure. So we'll be using Draw.io to actually design the high level architecture. And we can use Excel Draw where I actually explain each and every component to you. So let me just start with a little introduction as to what are systems and how system design architectures work and which are the common system design practices or architectures that people follow. So let's just get started with. So, what are system design architectures? So, these are nothing but how software components are organized and how they interact. So, okay. So, let's get started with some of the examples. So, we will be discussing few architectures. First one will be monolithic. Another one will be microservices. Then will be layered, event driven, and serverless. There are some more examples as well, but let's get started with these. And the more we go ahead, I'll be explaining some more about the rest of the components as well. So, how does a monolithic architecture works? So, how it generally works is for a monolithic architecture, you'll be having a single entity, and inside that, all the services will be stored. So, it will be something like, so you will be having like one application and it will be doing each and everything. So, it will be deployed as single entity as well, and it will be managed as single entity as well. So, monolithic we can consider as single unit. And monolithic architecture is something where the components are coupled and deployed as a single unit. So here in monolithic, we will be having like a single service, and inside this service, you will be handling your user data as well. You will be handling your admins as well. You will be handling your database queries as well. Whereas any other services that you have, all of those services will be coupled and put inside a single code base. So it will be deployed as a single entity. These are simple to use. These are something, if you want to start an application, just you have a thought and you want to create something of your own, maybe you can start with a monolithic architecture. And once the architecture becomes a little more complex, it can be then divided into maybe a microservices architecture. So the second entity will be microservices architecture, where there are one or more independent services that will be deployed. Now, coming to any example of monolithic uh, architecture. So, as I explained you, these will be a single entity which will be created and then deployed. So, these will be simple to build, but these will be very hard to scale. So, if you want your services to not fail at high load and those things, these services will fail at that. So where are these generally used? So examples include e-commerce platforms, or maybe legacy banking systems, or these can be operating system as well. You have seen inside your computers, when we used to install operating systems of our own, we used to have like a single disk, and it will be a single file that you will be then installing, and it will simply install your complete operating system. Now CMS like
నీకు
WordPress.
ఇప్పుడు నీది నువ్వు చూసుకోండి.
Any queries, guys? Okay, I'll continue. So this will be a little fast, as well as we'll be talking a lot of things over the top. So anytime if you have any query, you're not able to understand anything, you can please let me know, and we can stop and take a pause. So this is a mid to senior level course, but I'll make it as simple, because going ahead, you will be using these things to actually build systems, and anytime an issue happens, it will be based upon any of these. It can be new, it can be, but this will get you prepared for actually seeing the bigger picture. So as I was coming to another example of monolithic can be hospital management systems, where a single application is deployed, and these can be used to actually manage a lot of the hospital activities. Now, microservices architecture. Now, what happens inside a microservices architecture is you'll be having like multiple services, and these will be connected with each other in such a way that they want to interact. So these can be a call coming from the client to one service, can be distributed among two services. Maybe if you have like another service, the request can be distributed among other services as well, and there can be a chain of services as well, where subsequent services may be dependent or independent on multiple services. So this will be something like a monolithic architecture we just discussed, where a single service is deployed. Now this is a microservices architecture. Now, what is the major benefit of breaking up your application into small, independent, deployable uh, services? So, what generally happens is these are loosely coupled services that communicate over the network. And what happens in case of microservices architecture is, in case of failure of any of the services, there can be load can be distributed among different services. In case of failure of one service, maybe the fallback value can be coming from another service. So these are some of the applications that a microservice architecture will be providing. Examples include booking.com. You have seen like inside any booking application, you have like a flight, hotel, notification. So all of these services are deployed as separate services, and these are managed as separate services as well. Now, another example is Netflix. So the architecture that we will be discussing is also based upon microservice architecture, where they are using streaming, recommendation, billing as separate services, and these bring out the best use case of distributed load. So any traffic that will be coming for streaming will be distributed for the streaming purposes. Any request that will be coming for billing will be distributed as a billing service. And similarly, different services can be distributed among different services. Now, another example is Uber, where the driver matching service is separately deployed, the payment service is separately deployed, billing service is separately deployed, and trip tracking can be a separate service. Now, what are the advantages of using a microservices architecture is these are faster deployment services where each and every service can be taken as a separate service, and different updates can be faster deployed on these applications. So you need not depend upon all the services to actually have an update to actually deploy it, but different services can be worked with different deployment speeds as well, and the maintenance also becomes quite easy because now you know which service is failing or which API call is failing at which service. Now, so we have discussed monolithic architecture, we have discussed microservice architecture. Now, in between these comes n tier or organized tier architecture. So we will consider this like organized tier architecture. Now, what generally happens in an organized tier is you will be having like a single application, but inside this single application you will be having like multiple tiers or multiple layers. So generally in a layered architecture, the top layer will be generally the presentation layer. The middle will be your business layer. And the third layer will be something like database layer. Now, just like I've represented this as three different services, this can be n tier. So these can be different layers falling back on different services. So these are layered. Now, why are these used and when are these used is these will be used like small to medium level applications. These are good for performance. These are highly scalable. And you might have seen something like enterprise applications or Microsoft Word or something like that. These follow this layered architecture. Now comes another architecture. This is also one of the most used in the recent years architecture. So this is quite important to understand. This is event driven architecture or asynchronous messaging. Now, what generally happens here is these will be decoupled services. Now, what is a decoupled services? Now, generally what happens in a coupled services, when you have like two services connected with each other, in case it is like a REST architecture and it follows the request response architecture, what generally happens is, for example, this is service 1 and this is service 2, and the service 2 at one point of time is offline. Now, the service 1 will also fail because it won't be able to receive the response from the service 2. Now, in order to overcome this, asynchronous messaging or event driven architecture was created. Now, what generally happens in an event driven architecture is these services will not be connected with each other and these will be decoupled services. Now, how a decoupled service generally works is you will be having like service 1 and a service 2, and in between these you will be having like a broker or router. And the service 1 becomes the producer. So these will be producing the events in the form of messages, and these messages are then sent to the routers, and then from the routers these are then given to the receiver. So the second service will be receiver. Now when we discuss Netflix, this will also come into pictures. You need to remember this principle, how generally it is working. Now how a broker works is, broker is nothing but a server which will take the messages based upon the topic. So a router will distribute the messages among different topics, and a replica can be created at any point of time. Now what generally happens is, when a message is produced by the producer, it is then saved inside the broker as a topic. This topic can be any protocol of messages that you have created. For example, you want the user data to be actually given from producer to receiver. Now topic 1 can only be associated with user data. Now topic 2 can be associated with admin data, or topic 3 can be associated with maybe transactions coming from another source. So these messages are then transmitted through topics, and these brokers can then be replicated based upon your load. So what generally happens is, the producer will create the message, it will send to the broker, which will store those messages based upon the topic, and these messages can then be distributed among multiple brokers. So what generally happens is, the producers will not wait for the response, but the messages will send to the broker, where it will be queued to be processed, and based upon the availability of the receiver, it will be then consumed by the receiver. So for example, your producer can create like 500 requests, and your receiver is something which can only accept like 100 requests. So what generally happens is, in a simple microservice architecture, the throughput becomes like 50 transactions only, or it will generally failed after the if you are keeping like asynchronous messaging, yeah, the heap memory will increase based upon the traffic load, and the service too fails. Now what this becomes is, in a microservice architecture, this can become a bottleneck, and this can become a failure of the complete architecture itself. Now what happens in a decoupled service is, the messages are then given to the broker. Broker then saves the messages and puts them in a queue to be processed by the receiver. Once the receiver has that availability to process those messages, then the messages will be consumed and a response will be generated, and then the producer will receive the response, and the communication can happen. And if you want multiple messages to be processed, you can increase the size of the brokers, you can increase the replica count of the brokers. We'll see an example of this when we discuss Netflix. So keep in mind how these things work. One will be the producer, one will be the receiver, and in between lies the broker. Now what are the advantages of using such an architecture? It provides a real-time agility. So for example, you have like 50 requests coming up, and in the next second you have like 500 requests coming up. Now the broker can be made to replicate based upon the request, and then these requests need not be throttling on this receiver to create an application failure. Now, examples of this is Apache Kafka or Azure Event Hub. This is also an example of event-based architecture. Now, let's speed up a little bit. Now, let's discuss a serverless architecture. What generally happens in a serverless architecture is no service is required for deployment. Based upon the service request, services are brought up and scaled depending upon your load. AWS Lambda is one of those examples. What generally happens here is you will deploy the service as a function, or it can be any static HTTP page. So what generally happens is, based upon the load, new instances will be brought up and functions can be used as a service. So where are these used? These are required or used where the operational overhead is too much and automatic scaling is also required. So these are pay as you go. So in case you are not using any service, it will be scaled down to zero. Once you start using those services, it will scale up based upon your requirement. These can be scheduled, unscheduled. So examples include something like a cron job. So for example, you have set it upon a timer. So during that time, a computational power will be provided to a cron job. That script or the automation script or any process will be run, and then the cron job will get destroyed or the instance will scale down to zero. Or for example, these will also be used in something like an e-commerce flash sale where the load is not known and you have like a specific HTTP page where you have like all the uh, uh, products that are available for sale. So you'll create a separate HTTP page or a service, and these will be deployed as a function. And based upon the load on the flash sale, these will be scaled. So this will become a serverless where a server is not required, but based upon the load, a server is allotted and requests are received. Servers are generally cloud managed. So you will generally find some similar serverless application available with all the cloud providers. So these are generally cloud managed. Now, let's skim through few of the examples. I'll just briefly explain what are these. So you have another architecture, which is peer-to-peer, which is used in blockchain and those applications where what happens is multiple peers will be storing replica of the data, and these are constantly among communication with each other. These can any HTTP protocol, or they can follow like gRPC protocol for communication, and these will be all of them will be carrying the same state, and request and response can be received from any of those peers. So blockchain or cryptocurrency is one of the examples you might have heard recently that follows peer-to-peer architecture. Now, another architecture will be master slave architecture, where one service lies at top and multiple services are managed by this single service. So the master will be responsible for managing these worker nodes. These worker nodes will be managed by the masters, and the worker nodes are responsible for managing the loads. So one architecture you might have heard of is Kubernetes architecture. So you might have seen like Kubernetes architecture, you have heard of control plane, where it acts like a master, and you have like slaves or worker nodes, which will generally be the instances where you actually deploy your services. So it can be GKE, AKS. So these follow master slave architecture. Now, another architecture is microkernel architecture. This is also an important architecture. You might have seen it many places. Now, what is a kernel architecture? You have a single application, you have deployed it, and on top of that application, you install plugins to increase its functionality and usability. So examples include your browsers where you simply Chrome browser where you simply add different plugins based upon your use cases. And similarly, you have seen like your IDs, VS codes, where you simply download plugins based upon your requirement. So these are some of the architectures you will be seeing one or two. I've given you a lot of examples. So any doubt so far with these architectures? Other than that, we'll go ahead with the that concludes this topic. We will be discussing these architectures more in detail when we discuss those real life examples. But any questions so far? Otherwise, we'll move ahead. One, two, three. Okay, good. So now let's come to something that is part of every recruitment process. So whenever you are provided with a use case, for example, you need to design a social networking site, or you need to design a video platform like YouTube or Netflix. So generally you might have seen that people are starting with the capacity calculation or the estimation for how your applications will be designed. So these are called back of the envelope. So what generally is the back of the envelope calculation? So these are used to actually define the capacity or the load, or this will give you a basic idea how big your system needs to be in order for you to facilitate all the requests. So back of the envelope calculation is generally done for traffic. It can be done for storage. It can be done for bandwidth. It can be done for memory. So what generally happens is the back of the envelope calculation will, what is this calculation? First of all, let's get into something like this. For example, you have like an application like Netflix, where you have like 250 million DAU. What is DAU? DAU is daily active users. Now, in every system design interview, you will be given with something like a DAU or daily active users. You need to design Netflix where you have like 250 million daily active users coming up, and that's it. If it is something like this, is only the input that is provided. Now, how will you define the traffic, the storage, the bandwidth, the memory? So what we will be doing is, for example, now a lot of this comes up to assumptions as well. Now, if you're provided with 250 million daily active users, you can assume, because at this point of time, you are only concerned how you're actually designing the application. So for example, let's not assume Netflix. We have an open sourced version of Netflix. Let's assume Netflix 2. You can come up with an assumption that each user makes like 2 read requests per day. So this will be something like 250 million into 2 requests per day will give you something like 500 million requests per day. Now, whenever you're designing a system, you can be concerned with the daily active users, but when it comes to the system design, you're only concerned with how many requests your architecture will be handling. So That's why we have assumed like two read requests are made. For example, two movies a person watches and two read requests are made every day. So we'll come up with something like 500 million requests comes per day. Now calculating this will be something like 500 million divided by, this is per day, so we need to convert it into hours, seconds, and this comes up to be, just a second, so we can assume it's something like 5.8 k request a second. Now this is something that you can use to actually design your systems. So coming to another point, which will be the storage. For example, for one video, you require like 50 GB. And let's assume I'm an admin, I have a smaller company. Let's assume like I'm just deploying 2 movies per day. Now, I'll explain something Netflix uses, that is transcoding, which is converting this 50 GB of data into something like 100 different versions of the data. And if we have to convert it into like something like this, so one video will be something like 50. I'll explain transcoding and why it is done. But for the timing, let's assume like this 50 videos, 50 GB movie I have already received. And now I need to convert it into 1,000 different versions. So I will be doing like 1,000 different versions I have. Now I'm also putting like 2 movies per day. So whatever this value comes up to be, it will be in petabytes or something like that. So let's assume it's like 50 petabytes. So 50 petabytes of data per day. So similarly, you will be defining for bandwidth, memory, and similarly, you will be defining the load of your application. Now, generally, if it is only concerning with the interview, you can stick to traffic and storage. But generally, in a real life application designing, you will also calculate the bandwidth and memory. Now, similarly, we will define the bandwidth, whereas how many Pala services we need to create to actually achieve that bandwidth, and how much memory we actually require, or the computational power we actually require to actually host a lot of those applications. Now, let's start with Netflix. I hope this topic, back of the envelope calculation, is also clear with you guys. Any doubts so far? So whenever any topic like this comes, a lot of it comes down to assumptions, but you can always come up with requests per second or how much bytes of data per day you require. Now let's start with the architecture for Netflix. And by actually designing Netflix, we will actually understand a lot about Netflix as well. So for example, you are a user. Now, in front of you, you will be having something sort of like a desktop. And you simply either go onto the website, or you have like an app installed based upon your application. Now for Netflix architecture is generally divided into 3 major categories. First will be the CDN, Content Delivery Network. For Netflix, it uses OpenConnect. I'll explain each and everything. Let's just get through the terminologies first. Second is client. These are your web apps, iOS applications, Android applications. So these will be your clients. And the third is the Netflix backend. Now, this backend is responsible for movie recommendation, your data storage, and everything. So, what is CDN or Content Delivery Network? I hope you guys are familiar with Content Delivery Network. If not, I'll briefly explain it. So, you have like the world's globe, and for example, you have like a main server sitting inside the US. Now, I'm sitting in India, so request comes from India. Now, in order for you to actually provide response to this request, I need to connect with this server in California. Now, this produces a lot of delays. So I do not want my request to actually take like 30 seconds to actually reach the server in California and then come up with a response. So what generally happens is, for example, I have like a master node. Let's consider this like a master node. Now what happens in a CDN is a replica edge nodes will be created across the world. So I hope you guys are familiar with the regions, zones, the concept. If not, so it is something like the globe has been divided into different regions, US East, US West, and inside those regions, there are specific or different zones. These can be either one zone, two zone, or three zones. It can be any number of zones. And inside those zones, you have like multiple data centers. So my request, I do not want it to actually move to California. I have a server running in maybe uh, Malaysia or even India, and I want my request to actually be responding to those. So now, how does a CDN work is you have like a master node, and these will be your edge nodes. Now, what are edge nodes? Edge nodes are nothing but a replica of master nodes, and these are situated in different parts of the country or the world. So, what will happen is if I have like a master node in California, I'll be having like multiple edge nodes across the world, and these edge nodes will be responsible. So, whatever is the nearest edge node that in corresponding to my equation, my request will be received by this edge node, and these edge nodes will be providing me the uh, server. Now, how Netflix uses this CDN is they have something like, for example, you have like an master node. So it will be your original server. And then you will be having like multiple edge servers. Now, how Netflix works is it has worked with multiple internet providers to actually have their open connect servers placed at different locations across the world. So, for example, if the movie is being deployed on one server, you have like multiple open connect servers. So, this will be an OCA, which will be an open connect application. This will another OCA. This is another OCA. This is another OCA. This is another OCA. This is another OCA. OCAs are nothing. These are open connect appliances which are deployed at different zones different regions, and based upon your location, your application will connect with the nearest Open Connect appliance and then provide with you the data. Now, how Open Connect CDNs work is Netflix itself stores the complete movies in their CDNs. So, for example, you are sending a request to an OCA in Malaysia. So Malaysia OCA has the complete copy of every data that is present in the original server in California. So that's how CDNs work. And this principle, Netflix has implemented using their Open Connect servers, which are deployed across the world and which are used to actually connect with your services to the nearest. So for example, you have something like this. Your applications will then be connecting with so you have like Open Connect defined here, and your application connects with this. Okay, so these will be your OCA, which is Open Connect appliance. Okay, now, but how are the movies recommended is a different picture. Now, how your recommendation system works, how your data is saved and everything. So now Open Connect is just one part of the story, which is actually storing the movies. Now how movies are actually coming into picture, which recommendations you need to follow, how will you be receiving the recommendations, all of that resides in AWS. So this is Open Connect, this is one cloud provider. And now for another cloud provider, we have AWS. So all of the backend services, monitoring services, and everything, Netflix saves in AWS. Now, how these are coming into picture, let me just explain. So once you have like you are the viewer connects with an application. Now these applications are clients. These can be web apps. These can be your iOS application, Android applications. Now let me just explain a little bit about which technologies they are using. So for web app, they are using React with CSS, HTML. Now for their mobile apps, they are using Kotlin or Swift, depending upon either it is iOS or. So that concludes our client. Client will nothing be simple applications, how they are designed. You actually see the UI. That's how it is actually created on the front ends as well. Now, the main thing is what actually is happening at the backend of Netflix. So that is something that we will be discussing. Now, CDN we are familiar with. It is something like this network which is placed across the world. There are Open Connect appliances placed across the world. These store and are in sync with the original server, and these provide high availability to your Netflix applications. Now let's come to the backend, which is the backbone of Netflix, how recommendation system works, how the load is distributed, how traffic is coming into picture. So let's do you guys want to stick with Excel Draw, or do you want me to create the complete architecture here? I can create it both ways. Any recommendation, guys? You guys are still here, right? Hello, am I audible?
Anything is okay.
Okay, okay. Sure, sure. Okay, then maybe for the low level, we will consider Excel Draw and keep it here only. Okay. So let's coming to, once you have your application, it is connecting with the Open Connect, and now you have like a backend where the recommendation or everything happens. Now, how that is coming into picture is the first component is Elastic Load Balancer. So let's assume this as ELB. You are familiar with Elastic Load Balancer. This is a service provided by Amazon. Now, what generally happens in a load balancer is you will be sending the request, receiving the response, but the load will be distributed based upon how many requests are actually coming from the server. Now, how ELB works is you have like a load balancer. Now, how Netflix is actually managing this is you have the requests coming up. Now, these requests are then divided based upon available zones. For example, we have a request coming up. You guys are familiar with load balancers. What generally are load balancers?
Yeah, it distributes the load to the
Yes.
backend services.
Yes. So these are used. So for example, an ELB will be used to actually distribute your load based upon your request. For example, if you have like 500 requests coming up and one of your servers can support like 500 requests, and if you have like 1,000 requests coming up and you have like two servers, it will distribute your load like 500 requests on this and 500 requests on this. Now, how ELB is working and how it is actually implemented is something like this. So this is, so you have like two level load balancing done by Netflix. So as I just explained to you what are zones. So what will happen is anytime a request comes up, it will first be distributed among different zones. Now, how generally that happens is, so Netflix follows round robin load balancing. What is round robin load balancing? The request will be distributed equally with an interval. So, for example, first request will be given to Z1, then the second request will be given to Z2, then third request Z3, then again another request will be given to Z1. So, this is round robin. Request 1, 2, 3, 4, 5, 6. It will be distributed like this. And now how Netflix uses this is the requests are first divided among zones, and each of these zones will have its own another load balancer. And what that will do is it will distribute the load among instances. So what will happen is, for example, ahead of this, you have like multiple instances. For example, you have like 4 instances here, 2 are here, 2 are here. So for example, these are multiple instances and these are connected with different load balancers. Now, how it is distributed is, now here it will also distribute among instances. Now you have like an application or a service. Now these services will also have a replica. And for example, this is I1, This is I2. This is I3. Let's just delete this. Let me just create it for this only, and you can understand from here. So how it is happening. So for example, you have like multiple instances connected with this load balancer as well. So tool level load balancing. So what happens is the request will be coming to this load balancer. It will then be distributed among different zones. As I told you, different zones will be having their different data set centers. And so this will be distributed among zones first based upon round robin load balancing. And then another load balancing will happen at instance level as well. So for example, inside this zone, you have like multiple instances. Now the load will also be distributed among I1, then I2, then I3. And similarly, it will be done for this load balancer as well and this load balancer as well. I hope this concept is clear with everybody. So that's how so many requests. As I just told you that Netflix almost takes up like, I'm just saying like 2 requests, you might be doing like 10 requests per day. So we have to create a system who can handle like 6K requests per second. Now, how 6K requests will be handled? It will be distributed among separate instances. So Netflix uses millions of instances which are deployed on AWS. These are nothing but EC2 instances, and that's how load balancing is happening on Netflix. Now, once you have your load balancer, now this will send out the request to something like Zool. This is Zulu. So how Zulu works is, and what is Zulu? Zulu is gateway service for Netflix. Now, I hope you guys are familiar with gateway service as well. What is a gateway service? Gateway service is nothing but you can consider it like an reverse proxy, which can actually manage your APIs. It can actually work your APIs. So instead of simply sending the request to the server, you will be having like a gateway service, which will be having its own backend pools. And based upon your request can either be decorated or anything that needs to happen on your request, either authentication and those things, these can be managed through gateway services. Now, how Netflix designed its gateway services, let's keep it like ELB. Increase the size. Now this is Elastic Load Balancer. Now comes another service, which is Zulu. Zulu is what? Gateway service for Netflix. Now how Zulu works is, Zulu comprises of some components. Let me just draw those. It uses multiple components, and I will explain. Let's zoom it like this. So request comes up to Zulu from the Elastic Load Balancer, and a response needs to be generated. Okay. Now, when the request is received, it is received by Netty server. Now, what is Netty server? Netty server is nothing but a reverse proxy server that Netflix has created, which will in turn send its request to an inbound filter. Now, what does this inbound filter does is, it will decorate the request So for
Cylinder
example,
full.
yes, Bhavani?
Yeah, please
Okay.
proceed. Sorry.
Sure, sure. So what happens is a request is received. It is then received by a Netty server, which is a reverse proxy server, which sends this request to inbound filter. Inbound filter will decorate this request and send it to endpoint filter. This is nothing but endpoint filter. So now we understand elastic load balancer. Now we are coming to gateway service. As I told you, gateway service is required to actually receive the request, maybe manage or work something on the request, and then send it to the backend. Now, how generally, what generally happens at a gateway services, you can either do authentication, you can do like rate limiting, you can do like request response transformation, you can do like API versioning, you can do like analytics and monitoring. So authentication, like a request comes and you want specific users to be using that, you can implement authentication. Now rate limiting, how it happens is you can actually limit the requests that are coming up, and you can limit the request going to a specific service. So that can also happen. Now you can reform your request response like we are doing here. So as I just told you that the request and response will be decorated through inbound filter. Now API versioning and those things and analytics can also be done at this point. So what generally happens is the request is received by Netty server, it is given to an inbound server, inbound filter. Inbound filter will decorate this service and send it to endpoint filter. Now this endpoint filter is the one communicating with your backend services. Okay. And now, once it receives the response from the backend service, it will send that response to an outbound filter. Now, what does an outbound filter do? It does the same thing. So for example, you have sent a request, you wanted to decorate it with some more parameters. You just did that, send it to the endpoint filter, it sends it to the backend. Now backend sends a response. Now that response also needs to be decorated or something needs to be removed. Now outbound filter is responsible for that part. Now, once you have received it from the outbound filter, it will send it back to the Netty server. So this will be your request. This will be your response. I hope this is also clear to everybody. So what generally is happening is your request is coming from your ELB to Zulu, and Zulu then sends a response to load balancer. Okay. Now, what happens? Now the request has been received by your application gateway. It has been populated, depopulated, and now it needs to connect with the backend services. Now the first backend service we will be discussing is Hestrix. Now what is Hestrix? Hestrix is the API management server. So what happens here is a lot of microservices are created. And requests will then be sent to your backend server or application gateway. Now, what is Hestrix and how it works? These are the backend services. These are nothing but microservices deployed. So we have seen this architecture, right? Multiple microservices are deployed. So for example, how Hestrix works is, so I just told you, like you have this endpoint filter. Now this endpoint filter is connected to millions and millions of microservices. These can be instances, these can be EC2 instances, these can be replicas of the same service. So as I told you, in a microservice architecture, you will be having like multiple services, and the connection goes something like, we'll go from here, then the connection is going like this, then the connection is going like this. Another request comes up, user request, it goes like this, then it goes like this. Maybe some connections are happening here as well, and then another service is requesting something like this. Okay, let's assume this architecture. Now this is something that Netflix has designed, and this is used this is designed in such a way that it is used to reduce the latency and provide fault tolerance. Now, how this provides fault tolerances? For example, let's assume this is service 1, this is service 2, this is service 3. Here you have like service 4, 5, 6, and something like 7. Now, let's assume one of the services, like service 3, fails. So you draw with this service fails, or for example, this service fails. Now, what will happen is, for example, the request has come, it was supposed to get a response from request service 3. Now, Netflix has designed its microservices in such a way that in case of any issue with service 3, the same output or the minimal output can be driven from service 6. So how it does that is, it will be using something sort of like a default value. So for example, you have seen Netflix, you search something like horror, your genre, and somewhat your network is not working or you're facing some issues, and many a time you will find that based upon, first it gives you a response based upon your recommendation. If not your recommendation, it will still give you the top listed horror movies in your zone. So it works something like this. So what generally happens is, whenever a request fails or one of the services fail, it will fall back to the default values. Okay. Uh, either and also one more thing that it will do is, for example, for each and every service, it will also provide a timeout. So for example, any request that is not received in 1 millisecond, it will reject. So it will fall back to default values or something like that. And these architecture can then, since this is decoupled, this can be used to actually drive the metrics from a lot of services. So here you see, for example, the third service is failing or the seventh service is failing. It will fall back to the default value or use another route to actually provide the best architecture that is possible. Now, how Netflix achieves this is achieved with stateless architecture. None of the services actually store any state. These are stored either in S3 buckets or Cassandra or MySQL. And since it is not dependent upon any data that the service is saving, it works on a stateless architecture, and then it actually fallbacks to the default value. It will simply give you any response so that none of the actual critical services fail. So for example, since service 2 is critical, let's assume this is a critical service. So it will not use the load in such a way that all of the requests are coming up to this critical point. No, it will distribute in such a way. Hystrix main application is it will distribute the load in such a way that same response can be driven from either service 5, either service 6, and it will use and design and manage it in such a way that no timeouts happen. Second thing it will do is it will thread pool management. It will default values. And it will also have specific timeouts defined. So now we have seen some architecture. We have seen how OpenConnect works. We have seen how Elastic Load Balancer works, and it is integrated in Netflix. Now, once the request is received, now it will go through the gateway service. It will be populated, depopulated, and then it receives the Hystrix, which is nothing but API management service, which will distribute the load among a lot of microservices. Now, these microservices can be divided into two types. These can be either critical microservices. These can be your billing board. These can be your billing service. This can be your recently watched service. So these are critical service, and another will be non-critical micro services. Now, it is designed in such a way that my critical services are fault tolerant, as well as latency with critical services will be always low, whereas rest of the microservices will have maybe distributed load. It can be either very load consuming, but it divides it in such a way that the load is distributed among the whole architecture. Now, this Hystrix is already developed. They have already made it fault tolerant, and this is in maintenance stage. So I believe we have run over like 10 minutes. I will stop this lecture here. I hope everything is understandable till this point. Now, let me give you a broad picture of Netflix architecture. So Netflix architecture generally consists of a lot of services. So as you can look here, I have just explained to you how OpenConnect works. We have explained how ELB works. We have explained how Netty server works, request, response, inbound filter. We have seen how Zulu works, and we have also seen how Asterisk works. Now, this architecture, how actually Kafka is coming into picture, how these are being stored in S3 buckets, and how Cassandra, Titus, and Chaos Monkey comes into picture. Maybe this we can take up in the next lecture. Now I'll take up 2 minutes time to actually answer any questions so far. Otherwise, we'll go ahead and wrap up this session. I'll just stop sharing my screen. Once this complete architecture is drawn, I'll share these drawing links with you as well. But so far, I have explained to you uh, this part, different types of architectures, then how back of the envelope works, and we have started with the backend of Netflix. So, any questions so far? Oh, so sorry. I just saw this message. How does networks handle failover if CDN region becomes unavailable? Okay. So, for example, you are saying now, for example, any of these OCAs fail, or you can consider like one of the edge server has failed. Now it will fall back to the second nearest OCA server. The request time will be low. By the time we bring this one up, the request will be handled by the second nearest OCA server. I hope that answers your question, Swapna.
I got it actually. Yeah, thank you.
Okay. So in case you said like regions, but we are not constraining ourselves to regions. Each region will be having multiple zones. We are constraining ourselves to those zones when we talk about OCAs. Any other questions, guys? Otherwise, we'll wrap up. Okay, thank you, guys. Maybe we'll connect next week, this same time, and we'll continue with Netflix. After that, we'll be coming up with Uber. Thank you, guys. Have a good day ahead. Bye bye.
Thank you.